Therefore, as long as the top section of the building is in uniform downward acceleration, it cannot possibly be providing sufficient force to destroy the building. This may seem counterintuitive to you. You might think a falling block coming down on the lower section of the building would exert a greater force than a stationary block. But that is true only if the falling block actually impacts the lower block, which would cause the falling block to decelerate. The only way the falling block can continue to accelerate smoothly, as we see here, is for the lower section of the building to give way without significant resistance. If this rate of acceleration continued all the way to the ground, the building would fall in about 11.5 seconds. This is close to the observed collapse time. So far, I've been using the term block loosely. What we actually see here is the falling section of the building turning to dust before our eyes. But what is happening to the upper section of the building behind the dust clouds doesn't really affect this analysis. Given the fact that it is accelerating downward, the top section of the building, whatever its condition, cannot possibly be destroying the lower section of the building. The destruction of the building must be caused by something else.
So, I want to illustrate that. Time for a physics demo. Nail, wood, hammer, right? Now, if you hit a hammer and you hit a nail, to drive the nail into the wood, it's going to be resistance there, right? Yeah. And the hammer is coming down fast, and so there's more force than if I just set the hammer there, right? So if I bring the hammer down, it exerts a greater force. But as the hammer is pushing the nail, what's the nail doing to the hammer? It's pushing up, and that's what brings the hammer to rest, which is why you have to hit it repeatedly, right? It brings it all the way to rest. You got to do it again, and each time you hit it, the way it delivers more than its weight of force to the nail is by this deceleration. And without that deceleration, it doesn't work. Now, how can you arrange a situation where the hammer can just straight out accelerate? Well, if I drive it into styrofoam, I don't know if you can see here, if I just drive it into styrofoam, the hammer can accelerate all the way through because it only takes a small force to push it in, and the nail's not going to push back enough to slow down the hammer, right? So the way that you can get the thing to hit and continue to accelerate is if there's no resistance or very low resistance. So there's some resistance. It was like 36% of the weight is what we talked about, right? So that's the kind of the thing that's going on. You cannot have an excess of force. You can't have a buildup of force without having a deceleration. So the fact that it's accelerating says this is not exerting the kind of forces that are needed. Therefore, this is like almost like QED. This is like the end of the theorem. This can't be crushing that. It is falling into a pre-pulverized mass of material. Okay. Now there's some details in here which we've also thought through, but I mean that's the general idea right there. Okay. Now I want to come back to, this is the same video I just used. Okay. Okay. This is in AVI Demux again, so I can just run the frames any way I want. Okay. What I'd like you to first of all notice is what's happening to this upper block. So pay attention to this line here, where all the flames are occurring, and the roof line. And notice the separation of those two.
And what's the location of where the plane hit?
The plane hit right here. The flames are below, and so forth, right? Now, look at this. Here's the roof line. Here's that same line where the flames were. And this has not started moving down the building yet. Okay? So the very first thing that's being destroyed in this process is this upper block. So to call it an upper block is sort of fictitious. What happened originally, if you watch the NOVA program soon after 9/11, they said what it was pancaking floors. Now, the problem with pancaking floors as the way that these things collapsed is the core structure of these towers is 47 very major vertical columns that are huge, and they taper as they go up, but they're absolutely huge down at the bottom. And they're also very, very solidly interconnected. And this would just stand entirely on its own. And so if the floors pancake down, what you'd have is this big steel tower left behind. So in other words, the floor pancaking theory did not account for the destruction of the towers in this complete way that we actually saw. And so what NIST did was NIST rejected the floor pancaking explanation and said instead that the top section of the building acted like a pile driver to crush the columns below it. But what we just demonstrated is you can't crush the columns and have this effect that we observed of constant acceleration of this as it moves through it. So that's one. And secondly, that top section of the building destroys itself, and so it can't even act like a pile driver. And that one where we saw the northwest corner, you can't even see a top section at all. The destruction is going on right at the top of where we see it. We'll be seeing that again in a second. Okay. Now, I want to show you one other thing about, there's a lot of things, again, here to look for. But I want to run it down until we see the start of collapse. Boom. Now, I think what's on the screen up there is a little darker than what I'm seeing on my computer screen. But I started looking because Graham McQueen had talked about puffs coming out of the corners, right? Look at that. There's a puff. I don't know if you can see it on the screen right there. You see it? I'm going to move this back and forth a little. You see how it puffs out to the right? Right there. See that? Now, somebody go merrily. Go up there and the base of that puff, put your finger right there on the screen. Yeah, just a little up, down, right there. You see what we're talking about? Now, notice that the floors here are coming down. Oh, go back, right there. Right there. All right. The floors are coming down. What's happening to that puff? Is it following her finger or is it following the descending floors? It doesn't move. It's staying right where Marilee's finger is. So this little puff is fixed relative to something that's standing still, that's not coming down. Thank you.